So, hello everybody. This is the first chess timer talk, I don't know, I have experienced at least, or I have not yet experienced. I have no clue how this is going to work. But I've been asked and I've been told it's awesome, so let's see. As Heather said, it's crucial that you participate. And there was this rule of no questions in the first 5 minutes, which I think does not make much sense for this presentation. Because in the first 5 minutes I'm going to introduce actors and things, and if you don't ask if something is unclear, then the rest won't make sense to you, so ask questions, please. But before we dive right in, I'm Roland Kuhn. I work for TypeSafe. TypeSafe is the company behind the Scala language, the Akka actor implementation, the Play framework, Slick, and things like that. And just as a short explanation why that company can afford to pay me for working on open source software, we sell support subscriptions for that. But that's the only kind of explanation for why I can be here. So, who here in this audience already knows about the actor model? Please. Oh, that's great. And who knows about session types? Yes, you will be most needed, because I also don't know that much about them. That was the point of the talk. So first, a brief recap. So since everybody knows the actor model, it was presented in this paper by Carl Hewitt and his colleagues in 73 already. It models distributed independent agents. That's the core to it. It models distribution and nothing else. When an actor does something, it can only do something in response to a message, so it's purely message driven, and in response to a message it can send a number of messages, it can create a number of actors, both finite, and it can decide how to treat the next message. This is the implicit guarantee that things are processed sequentially, which makes it also suitable as a concurrency abstraction if you want to use it that way. No, I think this property was just crucial because Carl wanted to prove that there is this guarantee of service, and you can only guarantee it if, well, a single step doesn't take forever, I think. But that's my layman's interpretation. In practice, you won't write programs that send infinite number of messages, I think. You can have circular messaging topologies, but that is fine because in response to every message it just sends one more. So this is a finite number of messages, one per iteration, so to speak. But that's a pretty common pattern that people use. So you probably, even though you know the actor model, you probably have not seen much of Akka programs. Of course, I'm using Akka because that's the thing we develop. So first of all, this is Scala syntax. We define a message class, which is immutable. That's the default in Scala. So case class greet contains a string. Then we define an actor, a greeter, and def receive defines the initial behavior that the actor starts out in. When it gets a greet message, it will send a message to the sender of that message. It will create another actor from the grumpy props, which is a description of how to create a grumpy actor at the bottom. And then it will change its behavior for all the following messages into this grumpy state, where it just delegates the handling of the greet message to this new actor, which will send go away instead of hello. So this, in a nutshell, demonstrates all the features of the actor model. Now, you can see here several problems. You have the greet message that is defined over there, and you have the pattern matching inside the actor. But on the actor, there is no type ascription or anything. So the message that comes in here could be anything whatsoever. There are a few other problems. For example, the sender method here. That's a method that is called on the actor class, actor trait, and that gives you back an actor ref to which you can send messages. But since it's completely dynamic, sender, I mean, it could be whoever, it is completely unclear for whom the actor ref actually is, what kind of messages this actor ref can sensibly receive, what kind of messages you can send back to that peer. So there is nothing statically type checked here. Actors are very much dynamic. This is, well, it's active objects, but dynamically typed, if you will, in a statically typed language. So this brings me to my motivation for the work that I'm talking about. We have observed that when people write Akka programs, they are successful in writing quite complex programs, but as they grow, refactoring becomes more of a problem, because when you change something over here, you don't get all those nice static compiler error messages over there where you forgot to adapt accordingly. So making actors refactoring friendly, it was the initial motivation. And of course, avoiding stupid mistakes. In Scala, you can send the companion object to the greet class instead of a greet instance. And that's a different type, and it won't be handled by the actor, and you won't know it, because the actor will just discard the message. So this will provide some very weak safety properties. So to introduce the work that I have done for Akka to make it a bit more typed, this has been going on for the past 3 years or so, or 4 even, since basically before I started working at TypeSafe and being paid to do this. I thought, how can we make this more type-safe? And tried various things, and most of them failed. In the beginning, I was completely clueless, and then in the middle time, I was too ambitious. I used macros to express all these type relationships, but it was too clunky. It didn't really work. And the reason was that the sender method, which I intended to keep, is just, it is dynamic by nature. It doesn't fit into the type checking, so it needs to go. And then also, actors can receive multiple different kinds of messages. They speak some languages with other actors. Actors are about interacting and so on. And I used an approach using H-lists to formulate that this can receive integers or strings or greet messages or whatever, but that was just too complex and didn't really work. So union types would have been nice, but I didn't have them. So what I did, this is just a setting for the rest. So actorref itself, that is the handle that you get for the outside on how to send a message to an actor, has become generic in a type T, and that describes which messages it accepts. Then the behavior of the actor that receives these messages also needs to be parameterized in this type T, and then changing the behavior needs to retain the same type T because it's a static property. It's dead in the sense of the keynote, so to speak. And, well, this type is propagated in the creation process from behavior to actoref and so on. And currently it's just implemented as a very thin layer on top of the untyped actors to explore the properties of having a typed actor implementation.
Sorry, what does -T?
Minus T is the Scala way of saying that actoref is contravariant in T. So you can restrict the width of the channel that you provide, but you cannot enlarge it. Yeah, so if you have an actoref for fruit, you can expose it as an actoref for apples, but not the other way around. Yes?
You said that the union types didn't work. Was that due to the problem with Scala's type system, or something more like an inherent problem?
The problem with union types in Scala is that Scala doesn't have them, simply. Martin Odersky is working on the Dotty compiler, which might become Scala 3, and that should solve that because it contains intersection types and union types natively. Now there are attempts at introducing that by using H-lists and similar things, but it's just not really tractable as an add-on. Yes? So this type T would be the language that the actor implements. I can just go to the next slide to explain what that means. Can you read it in the back? Or I can read the important portions to you. So this declares an actor, basically. In the middle of the slide there is value initial, which is a behavior for commands. And this is the type T. Command is the type T in this case. And command is a sealed trait, which means it's a type where we statically know, which is closed, so only within the same file can you declare subtypes of this type. We declare the commands put and get, which extend command, and then this behavior that we declare here, which is implemented in the lower part of the slide, just needs to know how to handle commands and nothing else. So this is the way you go about it. You define the set of all messages that the actor understands as some common supertype of possibly many subtypes that are the different parts of the protocol that the actor speaks. And that is the type T that you bind the actor to.
So you're using subtyping as sort of a simple unit.
Yes, I'm using subtyping as a replacement for a union type. Yes, normally you could also say this is a behavior of get or put, but since we don't have that, well, let's just make a supertype and use that instead. Of course, that breaks down. Yes.
I was just going to say, could you make a behavior that only has get? Because get is a subtype.
Yeah, sure. Yeah, sure. And if you create an actor from that, it won't understand put, and that will be statically known. That is true. There is one obvious problem with this, namely that, well, I need to know all the types that I can handle here, and I need to be able to write them down here, such that I can make them subtypes. Yes?
How do you deal with changing of behavior? Third property mentioned.
So, changing behavior, excellent question. That is demonstrated here as well. In the untyped Akka, there was context become for explicitly changing the behavior. This has been the source of some errors and mistakes. So now it is implicit. Every step in this behavior declaration here, we have the case for a get. And the last thing that you do is you always need to return the next behavior. If you say same, that's a magic marker which does not introduce allocations and stuff like that for just not changing the behavior. But in the case of put, we need to change the state to incorporate the new value that was put into this map. What is ID? That's a correlation ID. So when you send a get, then the client needs to know to which the got corresponds. So typically in protocols, reply, you have some sort of ID.
It looks like this map doesn't express in its signature that it says total in the body, so that means that we can't know that you're actually preserving this totality.
Well, actually it does, because you say it's first of all, the behavior needs to be total. I don't have that on the slides. That's an implementation detail, I consider it. So the behavior of an actor is a total function from T to a behavior of T, plus some internal signal things that you also need to do. And then there are different ways of formulating the behavior. One of them says total, and that means that this thing needs to be a total function, and you get all the Scala exhaustiveness pattern matching checks that you would expect.
Just to clarify, so total in this case would mean that it exhausts all possibilities.
Yes. The pattern matcher is pretty good at telling you if you forgot to handle a case. So I think I'll need to quickly go over some of these. What can we do with this? Because I also want to get to the session types and then the contrasting part. So one interesting thing I looked at is we have actors and we can view them as active objects. Now we have the normal objects in Java-like languages and Scala and so on, where you have a class with methods. You can just replace this with an object that contains the message classes, which now fulfill the function of the methods. And you can even do more fancy things with restricting scopes of who can see which methods by having different traits and so on. So I think with this scheme of doing things, we can have a language that describes actors as with the same power as modules with methods in them. I didn't see anything missing, but I also do not have a computer science degree. So tell me if I'm wrong, please. Then the interesting comparison afterwards, so if I have a class, I use dot to select methods. And for actors, I use the exclamation mark for one-way message send, where the return is void or unit. Or I use the question mark operator for ask, where I get back a future. So this is, well, an interesting correspondence to me, but even more interesting is, and we're getting in the direction of session types here, we can do protocols. So let's say we have these messages and they are understood by some actor. Get session contains an actor ref of get session result, and then this actor that implements that will send back a get session result, which could either be an active session or a new session, and then these contain other actor refs. For example, after new session you have to send to an authenticate handler, and the authenticate handler will reply with an authenticate result and stuff like that. Yes?
I'm sorry, I think I lost you a little bit here. Do you do type inference or only type annotations and then check the type?
So, unfortunately, so this needs to be written down like that. There cannot be inference for that, as far as I know in Scala at least. You need to say what type of actor ref you expect here, because otherwise, where would this information come from? So these types cannot be inferred as far as I know.
Do you have any inference in your type system, or is it really
Oh,
type?
yes, Scala is statically typed with local inference. It doesn't do whole program inference, but when it knows the expected type of something, it will figure things out locally, expression by expression. There was a question?
Well, I was thinking, if you actually have a session type on some other agent, as seen from agent 1, we know that agent 2 has this session type. We can't know that there is not an agent 3 who's also talking to agent 2. So how can agent 1 trust anything?
Yes, so can we stash that question? So the question is, if there are multiple agents and they talk to the same interlocutor, how are session types useful, I think that's the question. Let's get to that shortly after this, because instead of...
You're 5 minutes left for your section. And then we'll all
Okay, I have lots of slides with questions. I can read the question, right?
Of course, yeah.
Okay.
We'll allow it.
Okay, so you can take this text and you can represent it as this image where you draw a box for each type, and the arrows means this contains an actor ref of that other type. And in this diagram you can see how the overall protocol progresses or can progress into different states. This, I think, is correspondent to global session types as I understood them. So let's quickly go there so I don't completely mess up. My understanding is that the session is a unit of conversation. It describes a conversation between, well, 2 or more parties. Well, let's first look at 2. The session type is the structure of that conversation between these 2 parties as a sequence of I send something, I receive something. This was originally done in the 90s, and then in 2008, multi-party sessions were introduced, and that's where this interesting question comes into play. And the primitives here are sending, receiving, a sequence of actions, choices, and recursion, as far as I understood them. Yes?
You're very good about going over the history as well, which is great. I just want to mention that the person who came up with session types, of course, is Kohei Honda. And this is worth mentioning because he unfortunately died a few years ago, and people should remember the great contributions that he made.
Very good point. Kohei Honda. That was the guy who invented session types, and yes, I've seen the name on many papers. Sorry for not putting it on the slide. Then there's a language for defining these protocols called Scribble, where, so this goes, I'm interacting with this question now. So, so you define a global protocol, like this diagram I've shown before, and then you make local projections as seen by every constituent or interlocutor. And then you can check whatever these agents do against their locally projected protocol pieces to verify whether they abide by the protocol or not. And the check whether or not the protocol makes sense, so whether or not some of the participants may get confused, is a check that you can do on the global protocol. As far as I understood, this has been proven to be safe, that you can globally verify a protocol that it does not confuse any of its participants. Is that true?
That sounds good.
Okay.
that you have to foresee the whole interaction and every participant, and when you made a very fixed scheme like that, then it's possible to redesign.
Yes. So first you paint the big picture, and then you scope it down to the individual parts. So from here on, I only have questions.
Can
Yes.
you go back to the previous slide and explain what linear types are?
Linear types. Oh, yes, that's an important detail. Linear types means that you can basically forget about things. In Akka or Scala, this is unfortunately not possible. So when I receive an actoref from somewhere, I retain the possibility to send to that actoref until, time in the future. And there is no way to invalidate that knowledge. You would need to invalidate that knowledge to express that the global protocol has progressed to the next state where that doesn't make sense anymore. Linear types can express this. So you have used this ability to send in this protocol step. Now it's gone, you can't use it anymore. That would be possible with linear types. Unfortunately, it's not with, almost all practical, mainstream languages. They don't have linear types. Unless, anyone have good ideas? What we should rewrite Akka in? Rust?
Yeah, so languages like Rust support linear types. I was just going to say, the key thing in linear is one, right? A linear function uses its variable exactly once. That's what a linear type does. It uses the variable exactly once. If you have a channel, you want to know you're going to send to it once at the given type. And if you copied that channel, if you used it twice, you could end up sending it two messages, which would violate the type discipline. So the key, easy thing to understand about linear types is they are use once types.
Okay, use once types, and copying is a special operation that is mostly forbidden unless, I guess, you...
It's forbidden when you're linear. There's
Yeah.
a special thing inside linearity that says, this thing here within the linear type system, you can use it as many times as you want.
Yep. Okay, so now we can try to progress into territory which I have not yet charted, so questions only. When I looked at Scribble, I saw that, well, you define the participants to the conversation, and then you define how they converse. But what about conversations where you dynamically add or remove participants? For example, you create new actors that start participating in this conversation. Has anybody, do you have any ideas, or is there something in the literature which helps us understand this, or is it even supported by Scribble and by multi-party session types?
That's a special case. Maybe you could reallow the sender and use dynamic type checks to let your potential participants make a choice of a particular role to play, and then you could build out the statically foreseen scheme and run it from there. So at least that will allow the agents to use the sender and do some dynamic type discovery to enter into scenarios that are known to be good, but it allows them to be flexible, to have different possibilities that they can go into.
So the suggestion is to just, there is a microphone. I think it would be better for the more discussion part that you actually speak into the microphone for the recording. So the suggestion was to carry the type information of the channels, send them around with the channels so you can dynamically check the types. Yes, that would be possible. I think it leads into another question. Yeah, this is kind of the question that it led me to, because I thought about that. Well, in Scala, transporting types means sending type tags around, and you can do operations on them. You can do subtyping checks and so on. Scala type system is Turing complete, so these type checks might not terminate. Well, so I thought about this, and I thought, so this is all about nominal types that you can capture. You have a name for this type, and you have a name for the type that you expect, and then you can check them against each other. The thing is it really necessary to have this nominal types? Is it conceivable to have a system that is more dynamic? I'm asking because in Scribble, you define the messages always by an operation name attribute, and then the rest of the values, which to me means it has a name. It is nominally typed in that sense, because you always require this name attribute. So what is your take on this? Is distributed computing fundamentally requiring nominal types? Raised eyebrows, heavy thinking. Because I have no clue. Just rip it out of there.
I just sit here. Okay, so I think the nominal types can carry a lot of semantics that are meaningful for people in the real life. So if you want to throw away the nominal types, you're going to throw away all the informal knowledge that programmers will have. So just getting rid of them because you can do more stuff is not necessarily a 1.0 plus. You know, it could be like 0.5 because you're misinterpreting the structure that looks like some other structure that you could recognize.
Yes. So my own conclusion is that you need to designate the semantic meaning of this blob of data, even when you have expressed it in such a fashion that people can just interpret it without a schema, like JSON, right? You can write down a message that can be parsed by everyone, but it's not clear what it means unless you have some designator for the semantics.
So I wanted to ask, what are the current ways of, so the question is, does it fundamentally need nominal types for the semantics? What are the current employed ways of solving the problems of agreement on semantics? Are there any current ways of solving it which do not involve nominal types?
Not beknownst to me. So what we normally do is we have a jar file that contains the protocol definitions, which are just Java classes, all nominally typed, and then you use them at all the places in your cluster. And so that solves the problem. You will need some discipline to evolve protocols, of course. You can't just change things willy-nilly. You need to add versions and stuff like that. But that's how it's normally done nowadays. But there was someone else. What's the definition of nominal types? So I'm a physicist, so bear with me. I think a nominal type is one which has been declared with a name, an identifier, so that the compiler knows what it is by just looking at that thing. It doesn't look at the full structure because from the name it knows the structure.
So if I have something that's a string but I've called it a user ID, then that's the nominal type is the user ID bit, and is it structural type is the other
Yes.
one? Is the string underneath?
Yeah, I think that's an interesting aspect. With nominal types, you can have a string, or you can have a wrapped string that is actually a user ID, and you can distinguish them even though their structure is the same.
So I've got an answer to a question. Ooh, that's loud. So in answer to your question, do you need nominal types? I would guess the answer is no, because Erlang is very successful and has no types whatsoever.
Yes, but in practice you always send a symbol that denotes the semantics of what you want to do in your tuple that is the message.
So now we just argue about what nominal means, and we could do that forever.
Yeah, okay, so I guess the conclusion is you don't need nominal types in the type system meaning of the word, but you always need to denominate the semantics of your operation.
Okay, so maybe we should just say we need names.
I guess so, yes.
Right, then we don't need to be so fancy. Okay, different question. You went through ordinary session types very quickly, and I'm really curious to know. I work with session types, and yet I sometimes feel like I'm a guy with a hammer running around looking for a nail. Session types being my hammer. What I want to know is, how many nails have you encountered? Do session type, ordinary, bog standard session types, yes, they don't do everything. They don't do dynamic extension. That would be nice. But within what you've looked at, have session types actually seemed useful, and where did they seem particularly useful?
So I must confess that I have not yet actually implemented all of the stuff that I would like to do. I have just implemented this very simple way of capturing that one message may lead to another, and that is extremely useful. It is also well, I have not yet quite concluded yet whether it is fully static or a bit dynamic already. I think it's mostly static in the sense that the structure of a picture that you draw of an interaction like that wouldn't change because that's written at compile time. So this would be fully static. What is not static is the allocation of who does which part of this protocol in my solution. Yet that's a difference to Scribble, where that is static. You just define that. Well, what is really useful in this is making sure that you define a protocol which does not confuse anyone, and you have a way of checking that everybody abides by it. And that is very valuable as far as I can see. So yes, I think just normal session types have lots of value.
Thanks, that's really helpful. By the way, I work with the Scribble people. I'd be happy to put you in touch with them.
Oh, cool. Yeah, talk to you afterwards. So, I don't know, what are the... Yeah, this is one of the questions I meant to ask of the academic population. So who here in this room counts themselves in the academic side of things? Okay. Yep. Interestingly, a minority in this room, but anyway. Scribble has this feature of saying interrupt, where you say, I'm waiting for that message from over there, but now I'm not interested anymore because something else happened. This means that the local decision needs to be propagated to the remote point where it actually also affects things. Because the state where we are in the global protocol, well, people need to kind of agree on what that is in order to meaningfully interact and not get confused. This is very simple in theory when you say, well, we have guaranteed delivery, so it does work. In practice, we do not have guaranteed delivery. So any number of papers I read, like actor model itself and so on, everywhere we have guaranteed delivery, assumed. How much of the theory actually depends really crucially on it? Or would it just be more complicated to allow for message loss? This is I think a big impedance mismatch between industry and academia, because yeah.
I'm afraid I don't quite understand interrupt. It seems like it might do something much worse than prevent guaranteed delivery, because of all the so an interrupt can happen while some other message is currently running, and we have no idea what the state is going to be. So it's hard for me to talk about much what interrupt would do when I can't even figure out what it does.
No, interrupt means I asked you something, and now I turn around and do other things, and then I figure out I haven't heard back from you, but well, I made my decisions already. So stop whatever you were doing. Meanwhile, you have gone and checked some other things and were just about to get back to me. And these messages that you are to interrupt and I get your response, they might cross paths on their way. The interrupt message might be arbitrarily delayed, so you might still carry out the work and respond to me, but I don't expect that anymore because, well, I interrupted you, didn't I? So this, in practice, this is really hard to implement. So the suggestion was to explicitly incorporate time and the timeouts. Well, if you have atomic clocks and you implement something like Google Spanner and you have the millions to make it happen, yes, of course, that's a possibility. No, what I mean is the notion of time itself is also local. For a physicist, I mean, that's clear, Einstein and so on, right? So.
I guess in general this has to do with distributed algorithms. So there's lots of papers of synchronization in the distributed algorithms paradigm where you can say, well, for example, vector clocks are a way to synchronize, but those might be too heavy for actors. I don't know the use cases. So if you want consistency, then you usually pay a price, and there's many distributed algorithms that can give you some sort of consistency.
That is true. We are using vector clocks, for example, in the implementation of Akka cluster, unsurprisingly, because we need consensus of who is in the cluster and who is out and who got kicked out just now, right? So there we use it. We have resends, we have very expensive handling of TCP reconnects and stuff like that to just be able to guarantee eventual delivery of a message. But it's just so hard to implement correctly, and therefore I'm asking, is it really the right default to design your algorithms for? Yeah.
I have an idea of Scribble, but does it have to be, when you interrupt next message, does it have to be a message, or it may be a local decision to ignore a response?
Yes, so in Scribble, it is a local decision and it will ignore responses, but it will also inform the other party so that the state doesn't diverge. So I start doing my own things then, because I make this breaking decision kind of, and you keep doing your things, and because you didn't hear of my decision, and then the participants might think that they are in different protocol stages, unless the interrupt is actually delivered.
And this matters for this global check-in, right?
Yes, so the global check, I think, assumes that the message will be delivered, but I'm not an expert on exactly that.
Time for one more.
Time for one more.
So I was wondering about, for these multi-party sessions, you might be able to skip in the scheme. So you could basically say that here's one of the players who's skipping these two steps. And what does that correspond to in all the others?
Yeah, so in that sense, I think that might be very difficult to get right, because skipping over certain things could just completely confuse matters. Does anyone else have a good idea? Yeah. So that's one I cannot answer.
Anybody?
Chris, do you have an idea?
No.
Okay, so now you know at least what I'm very interested in. So please find me in the hall, and if you have things to discuss on these matters, then let's just have a chat. Thank you.